In Module 2, Lesson 13, we're going to convert between fractions and decimals using equivalent fractions. To start the class, I posted 2 questions on the board. In the first one, what are some examples from the real world where decimals are used? And on the second, what are some examples from the real world where fractions are used? In our discussion in class, we would see a number of different examples for decimals. For example, money. The metric system uses decimals, and I'm sure there are many more that we would get. And as far as fractions go, fractions are used in cooking, they're used in measurement. Those are the 2 primary areas, and I'm sure more would come up in class. I would then follow up with the question, have you ever seen a recipe that calls for a decimal amount of flour? Say 2 7/10. And I would also ask, how do you think people would react if a local gas station posted the price of gasoline at $3 3/7 per gallon? So we determined from example 1 then that different situations in the real world require different representations of rational numbers. Because of common usage in life outside of the classroom, we may automatically know that $0.25 is the same as 25 cents, or a quarter, but for people who are used to measuring money in only decimals, $0.25 might not make much sense. Because of this, we'll need to write our numbers in different forms. If a number is given in decimal form and we need to have it in fraction form, we'll need to be able to change that form rather easily. So the value of the number 2 25/100 actually is easy to find if you can read the number the same way that I just did. 2 25/100 is 2. So we see that we can write the mixed number 2 25/100 simply by reading the number with its place value. That fraction can also be written in simplest form, and we do that by taking our 25/100 and dividing both the numerator and denominator by 25, since that is the common factor. We can see how we simplified 1/4 to 1/4, and that means the simplified version of 2 25/100 is 2 1/4. What is the value of the number 2 25/1000? Again, we know if we read the number correctly, 2 25/1000 is clearly a different number than 2 25/100. And when we simplify 2 25/1000, we get 2 1/40, because 1,000 divided by 25 is 40. And we can see that 2 1/40 is a much smaller fraction than 2 1/4. In exercise 1, then, we will practice converting each terminating decimal to a fraction. A terminating decimal is one that has an end. The digits do not continue. And then we'll rewrite each fraction in its simplest form. And we can see then the simplified versions of these decimals. Please also note that if it's a mixed number, you simplify the fraction only, and then the whole number portion of your mixed number remains the same. To begin example 3, we're converting fractions to decimals. We need to have a little discussion of what decimal means to begin with. So decimals, the word decimal means 1/10. It comes from the Latin word decimus, and you see that prefix, deci, D-E-C-I, used in the metric system, which also means 1/10 of a unit. The meaning of 1/10 would be when you divide something into 10 equal pieces, and one of those pieces is what you're talking about. So a dime is 1/10 of a dollar, and a penny is 1/10 of a dime. Decimals, then, specify points on the number line where you would repeatedly subdivide your intervals into tenths. You're taking your number line, and in between each number, you are dividing it into 10 pieces, equal-sized pieces. If we then use the meaning of decimal to relate our decimal place values, we would say that each place value in a decimal is 1/10 of the value of the place to its left. This means that the denominators of the fractions that represent each place value must be powers of 10. And then to write 3/100ths as a decimal, what we want to do is put the numerator in a decimal position, but that numerator needs to end, whatever number you have in the numerator needs to end at the place value position that is in the denominator. So in our example then, we have 0, and the 3 has to be in the hundredths position of the decimal. So in order for it to be in the hundredths position, we need to put a placeholder or a 0 in the tenths position, and then our 3 will be in the hundredths position of the decimal. If the fraction that we are trying to turn into a decimal has a denominator that actually goes into 100, we can write the equivalent fraction first and then write that as a decimal. Since 20 times 5 equals 100, we could do 3 times 5 for our numerator to write the equivalent fraction. So 3/20ths as an equivalent fraction is 15/100ths. And remember, the last digit of your numerator has to end in the place value position of your denominator. So our 5 needs to be in the hundredths position of our decimal. Let's try 10/25ths using the same process. So 10/25ths, 25 times 4 equals 100, so we need to also multiply the numerator by 4, which will give us 40/100ths. And remember, the last digit in your numerator needs to be in the place value position of the denominator, so that would give us 0 and 40/100ths. But in decimal positions, trailing zeros don't mean anything, so we could eliminate that trailing 0, and we would have 4/10ths. Let's try one more time with 8/40ths. 8/40ths will be a little trickier because 40 doesn't go into 100 evenly, but 8/40ths could be simplified And then we could write our decimal from there as well. And we see that 8/40ths can be simplified to 2/10. We divide it by 4 because we know that 10 is one of our place value positions. And then simply the 2 must be in the 10th position of our decimal. In our final exercise, we're asked to convert each fraction to a decimal using an equivalent fraction. We'll model how to do that in this lesson, but in lesson 14, we'll probably find a little more efficient way for many of these fractions. Starting with 3/16, 16 doesn't go into 100, and it doesn't go into 1,000, but it does go into 10,000. So we will look at how to get there. "16 times 625 equals 10,000. And so once we know that, we multiply the numerator times 625 as well to get 1,875. More importantly, the 1,875, that last digit in your numerator must be in the place value position of your denominator. Tenths, hundredths, thousands, 10,000s. 7/5 in part B is a little easier to get there. We know that 5 goes into 120 times. But even easier, we could convert these to tenths, since tenths is a place value position. And 5 times 2 is 10. So we see that 7/5 is 14/10. But we also know that this is an improper fraction. So in order to turn it into a decimal, we will have to turn it into a mixed number, and then it can become a decimal. 14/10 is 1 and 4/10. And then remember, the 4 needs to be in the place value position of the denominator, which is 10. So the 4 needs to be in the 10th place. 11/32 will be very similar to what we did with 3/16. But now instead of multiplying by 625, we would multiply by twice that amount, since 32 is 2 times 16. So our factor then will be 1,250. Correction on that, because 32 does not go into 10,000. We would need to go a little further to 100,000. And 32 goes into 100,000 3,125 times. Remember, in lesson 14, we'll have a little more efficient way to work with that. And 11 times 3,125 is 34,375. Looking at this number, remember the last digit in our numerator must be in the place value position of your denominator. So our 5 will need to be in the 100,000 place value. Tenths, hundredths, thousands, 10,000s, 100,000s. Finally, 35/50ths could be done one of two ways. We could double it, 50 times 2 equals 100, or we could divide by 5 and have our number be in the 10th place value position. And we see that 35/50ths is 70 100ths, and that trailing 0 can be eliminated, so we could also write it as 7/10. And we see that any terminating decimal can be converted to a fraction using place value. That was what we did at the beginning of our lesson. And a fraction whose denominator includes only factors of 2 and 5 can be converted to a decimal by writing the denominator as a power of 10. Equivalent fractions. Complete the problem set before moving on to lesson 14.